Once again, calculus students and those who seek the truth, let us work through this video with and just doing a bunch of examples of how do we find antiderivative of specific functions. So first, if we have a function e to the 17x, what would be its antiderivative? Well, its antiderivative would simply be e to the 17x, and then divided by 17 or multiplied by 1 over 17 would be its antiderivative. Because when you take the derivative of e to the 17x, you will have to also multiply by 17. So you need this 1 over 17 in order to cancel out that constant. And of course, you're going to add a constant here at the end. Second example, the sine of 3x plus 2. So it's antiderivative, so I'm going to deal with the outside function first. This will be cosine of 3x plus 2. And then I'm going to, we're going to have to add this negative in the front here, right, because the derivative of cosine is actually negative sine. And we have to keep in mind that the chain rule still applies. If we were to take the derivative of cosine of 3x, you would get a 3 in the front. So we have to adjust for that by dividing this by 3. So, I'm going to name this function f of x here, just so that I can check. Okay. So for this function, it's worth doing a quick check. So what would be f prime of x? Well, would be, I'm going to pull this one. This would be negative 1/3, right? And this is out in the front here, times the derivative of cosine of 3x. So the derivative of cosine of 3x is negative sine of 3x plus 2, times the derivative of the inside function, which is just 3. So now you can see that the 3 and the 1/3 cancels, and then the negative and the negative cancel. So we're left with sine of 3x plus 2. And once again, to bring home this point, we are able to take this antiderivative because the inside function here is linear. If that function is not linear, we're going to have to deal with some other trickier stuff later on. Well, I should say that the correct answer here, I also need to have the constant. So continuing on, what we're asked to find here is the antiderivative of 3 over e to the x. Now you'll probably point out that there is no quotient rule of antiderivatives that we've studied so far, but that's okay because we can rewrite this in the following way. This is really 3e to the negative x. So that means its antiderivative, f of x, would be equal to negative 3e to the negative x, or negative 3 over e to the x. So we can check rather quickly. What would be f prime? Oh, there should be a constant here at the end. F prime of x would be equal to negative 3, so if I'm going to go based off of this one here. Negative 3e to the negative x times the derivative of the inside function, negative 1. So the negatives would cancel, and I would end up with 3e to the negative x, or 3 over e to the x. Okay, so again, the beauty of taking these antiderivatives is it's always very simple to check, because we just have to take the derivative. I'm sneaking this one in here. I didn't talk about derivative of secant squared, or the antiderivative of secant squared yet. But if you know your trig functions well and its derivative, then it should be very easy that the antiderivative of secant squared is nothing more than tangent of x plus a constant. I will leave you to check this so that you could get some practice dealing with derivatives of the lesser known functions. And then for this function, the square root of x. So it helps to rewrite this as x to the 1/2. So that means that its antiderivative must be, oh, let's see, we're going to add 1 to that power, so this is x to the 3/2, and then we're going to divide by the new exponent here. So 1 over 3/2 is 2/3 plus our constant. And checking as well, if we were to take the derivative of this, we would have 3/2 times 2/3, which is just 1, x, 3/2 minus 1, which is 1/2. And look at that, this is exactly equal to the square root of x. So there you go, 5 quick examples here in how to deal with and how to solve and find specific antiderivatives. Thank you for watching and have a